Hello, this is the second lecture on message passing. This is a short one. In this lecture, we will introduce you how ThreadMentor handles communication links. But this lecture only provides you with the most basic form. Then the next lecture is a demo. So what is a channel? A channel is just a bidirectional communication link between two specific threads. It's just a highway, two lanes. One lane southward, then the other would be northward. So a channel can be used by two threads, one at each end, to send and receive message. A channel can be synchronous or asynchronous. Remember what's synchronous? It means sender blocks if the message is not received until the message is received. Receiver blocks if there's no message on the channel. Asynchronous means the sender and the receivers do not have to wait. Here, just like a process has an ID, ThreadMentor automatically assign a thread an ID. But in order to make your programming effort easier, ThreadMentor allows you to assign a user-defined thread ID so that you can build channels between two threads easily. A user-defined thread ID is just a unique non-negative integer selected by the user. That is you, the programmer. Channels in ThreadMentor use user-defined ID for identification purpose. So in the thread class, there is a name, user-defined thread ID, defined in the thread class. You could assign a non-negative integer. So in this case, if you assign a number to user-defined thread ID, that thread would have at least two IDs. The first one is the system assigned, which you don't need to know. The second one is the one assigned by the programmer. That is the user-defined thread ID. Giving a user-defined thread ID to a thread, you are able to use these IDs to build channels between two threads. ThreadMentor only provides you with two types of channels: synchronous one-to-one channel and the asynchronous one-to-one channel. So for synchronous one-to-one channel, it means blocking send and blocking receive. For asynchronous one-to-one channel, it's non-blocking send and non-blocking receive. Actually, ThreadMentor has more channel types, but we found out throughout the years in using ThreadMentor, students may easily get into some trouble if using other types, channel types incorrectly. For an example, ThreadMentor does have synchronous many-to-many channel and the asynchronous many-to-many channel, but we disable them all. So look at here. Here, X is declared to be a synchronous one-to-one channel. Y is declared to be an asynchronous one-to-one channel. So in this case, at both ends, there's only one thread. So it's because in your program, you may use many channels for communication purpose. It's wise to assign a name to each channel. And that the second and the third arguments are the user-defined thread IDs, so that we are going to build a channel called X, which is a synchronous one-to-one channel between this thread ID and this thread ID. Therefore, here, the first slide means X is a synchronous one-to-one channel. Its given name is chain-2-3. This channel is built between two threads whose user-defined thread IDs are 15 and 3, respectively. If you don't have the channel name there, you could just provide these two. These two are mandatory. You have to have the threads at either end of the channel. Without giving a channel any name, when you use a visualization system, you don't know which channel is doing what and between which threads. So here, Y is a asynchronous one-to-one channel between 15 and 3. The channel name for Y is CHAN-4-5. So this is very easy. Here, we only provide you two methods for each channel, send and receive. Of course, channel can be declared or allocated and using pointers. So here, let's take a look at a simple example. We use send method to send messages and receive method to receive messages. Here is the syntax. X.send means we call the send method of channel X. The send method requires two arguments. The first one is a pointer to a message. Therefore, your message has to be there. And you bring the pointer as the first argument. The second one is the size of the message. The opposite, receive, is the same, Y.receive. Here, you're going to receive a message from channel Y. And the received message will be stored at the area pointed to by this pointer. And the size of the message is here. Now, let's take a look at an example. Suppose we declare channel X. This X is not this X, because this is a different example. We hope to send an integer message into channel X. So we declare X to be asynchronous one-to-one channel. And we declare the message, which is an integer, MSG. Here, we want to send this message to channel X. So X.send a pointer to this message and the size of an integer. When this statement is executed, the content of this message will be sent through the channel X. So this is very easy. In reality, other systems send and receive could be more complex. Now, for the receive part, let's say Y is a asynchronous one-to-one channel. Y wants to receive a message which is 4 doubles. So we declare an area MSG of 4 doubles. Therefore, when we call Y.receive, the first one has to be a pointer to the area the message will be stored. And the size is 4 doubles. And then let's look at a more complex example. This is very frequently used. Instead of sending a single variable or an array, in many cases, the message could be a data structure. Here, we declare data to be a structure. The variable name MSG is a data structure in which we have 1 double, 1 integer, and a character array of 100 positions. So in this case, let's declare Z to be a synchronous one-to-one channel. We want to send this data structure to channel Z. So we take the pointer to MSG and we extract the size of this data structure. So this call means take the message stored here of this size to channel Z. Use an example to illustrate channels and send and receive. Although we have 10 slides, but the example is rather simple. Let's do a linear array sorting. Here, this linear array sorting example is used to illustrate the idea of sorting an array using a set of threads and a set of channels. Its complexity disorder n squared, not very efficient one. But this is a good example to illustrate the idea. Let's say we have a set of threads. Each thread has an input channel from its predecessor and an output channel to its successor. Each thread has a channel from its predecessor and the channel to its successor. The first time a thread receives a positive integer, it is memorized as the value n. Suppose I am a thread created with two channels, one incoming from my predecessor, one outgoing to my successor. Initially, I do not remember anything. The first time I call receive to get something from my predecessor, I get a number. Let's say a positive number. I memorize this number as n. Then I try to keep reading or receiving other numbers or positive integers from my predecessor. When I receive a number x, if the new number is less than the number I memorized, this thread sends the number I memorized to its successor and then memorizes the new number. For an example, suppose the number I memorized, n, is 5. And the number I receive is 3. Because the new number is smaller, then I send the number I memorized, 5, to its successor and memorize x. What does that mean? It means if a number is smaller than the current number I memorized, I always keep the smaller number and send the larger number, whatever the number is, the number I memorized or I just received, I simply send to my successor. This is the next bullet. If the new number is larger than or equal to the number I remember, I simply send to its successor. So let me sum it up. A thread continually receives number from its predecessor. If the new number is less than the current number I remember, I send the number out. And remember, there's a smaller number. If the received number is already larger, the received number will be sent to my successor. As a result, I always remember the smallest number passing through my threads. All larger number will be passed to my successor. There is a catch. Both steps involve sending some number to my successor. What if there's no successor? Then I build a successor and also build a channel between my thread and my successor. And then after the channel is built, send the number out. So this is easy. So the first two steps assumes that a thread has a successor. The third bullet indicates that If there's no successor and I have to send the number out, then build a successor and the channel to it, then send the number out. Why does this method sorted input? It's simple. Remember, the first steps that each thread must execute is, I only keep the smallest number passing through me. Therefore, the first step would only keep the smallest number. The second thread only keeps the second smallest number, because the smallest number will never pass through the second thread. Of course, the last thread in this chain of threads connected by a linear sequence of channels would be the largest one. Therefore, the number remembered by each thread is actually a sorted array of the numbers. So just find some way to print it out. Let's take a look at an example to illustrate this idea. Let's say the input values are 5, 1, and 3 in this order. We need a thread. Let me call it master thread. In this diagram, it's colored blue. This master thread just reads the input values and send the value to the sorting thread. So the master thread never sorts. It just reads the number and sends them out. Therefore, the master thread would get the number in this order 5, followed by the second one, and then the third one, 3. So this is the initial situation. Now, how do we know the data ends when the master thread reads end of file? It knows, okay, there's no more value. So the master thread chose a negative value, say -1, to indicate end of data. Here, let's say the master thread reads 5 and sent it out. Then the master thread reads the second value and sent it out. Finally, the master thread reads 3 and sent it out. And then when master thread tries to reach the input, and the file is reached, then the master thread sent out end of data. So this is what the master thread is doing. So let's say master thread is here. We create our first sorting thread. Master thread reads 5 and send the number 5 to a sorting thread. Currently, when the sorting thread is created, it doesn't have any number. So when this sorting thread is created and receive the first number, and this, because this is the first number, so the first sorting thread memorized 5. At the same time, the master thread sent the second number 1 out. Then this sorting thread received the next value 1. This value is smaller than the number it currently memorized. Therefore, the first sorting thread will send 5 out. Meanwhile, the master thread received 3 and sent 3 out. Now, for the first sorting thread, it determines that 1 is smaller, 5 must be out. So the first sorting thread build a new thread as its successor. Look at here. The first sorting thread's predecessor is the master, and its successor is just created, and the number 5 sent out by first sorting thread is still on the channel. Then we have the next situation. The second sorting thread is created and gets the number to it, which is 5. the first sorting thread received 3, and 3 is larger than its current number, so 3 is sent to its successor through the channel. Meanwhile, the master thread gets the end of the data, but the end of the data is still not there to the first sorting thread yet. Then, when first sorting thread receives end of the data, it knows its end of the data. The number I receive it is smallest, and then pass end of the data to the next one. Now, for the second sorting thread, it received 3. 3 is smaller than the number it memorizes, so it memorized 3 and sent 5 out. Of course, before it can do it, a successor must be built. And 5 is sent to the successor through the channel. Now, the first thread has already received end of the data, so the number 1 is the smallest. It could print it out, but we have to remember the dynamic behavior we will illustrate very soon. And then EOD, end of data, is sent to 3. Because the second sorting thread received EOD, the number it memorizes is the smallest one, so 3 prints it out and send EOD to its successor. So when the third thread receives EOD, it knows it's end of the game. And the third thread prints it out 5. Now, the third thread does not have a successor. It knows it's the end of the game. So what went wrong if we print the value out here? Well, it may not always be wrong. How do you know? Now, notice here, this thread, and this thread are run concurrently. How do you know? Suppose this thread prints out the smallest number is 1. This thread is the smallest number is 3. Okay, so or the second smallest number is 3. How can you be so sure that this printing 3 would be after printing 1? There's no such guarantee. Therefore, you have to find some way to overcome this issue. The next consideration is, this is the idea. What type of channels should be used? Synchronous or asynchronous? In this example, we use synchronous. But there's no harm for you to use asynchronous channel, because this system is run in a shared memory system. We don't have the timing issue. Okay, so this is something for you to think about. Now, here is the program. Because we only send integers out, therefore, we could set end of data to be -1. What if you may have negative number? What would you do? You could use a data structure. The first one is a bit or even a character indicating whether it's end of data or not. The second component is the data you send out. Now we define a value, a constant not defined. The meaning of not defined is when a thread is created, of course, it doesn't have any value. So let me use -2. Here is the sorting thread. It inherits everything from the thread class. The public component has a constructor, an index, and a thread ID. This is the user-defined thread ID. And this is destructor to remove the allocated stuff. And there is the channel, synchronized one-to-one channel. For the private section, we have the thread func. You remember it? The index is for you to construct thread name. And the number, this is the number to be memorized. And we have a pointer to the next thread. And this is the master thread, which is created to read value in and send to the next one. So it has a constructor and a thread function. So this is the class definition, which is easy. Now, just remember this, because we need to construct thread name. So your thread name may be sorting thread 1, sorting thread 2, and so on. So this is for you to do, giving a thread name. And number, this integer, is used to memorize the number sent to the sorting thread. So here is the implementation of the constructor of sorting thread. Remember, the first argument index is used for defining a name for a thread, and the thread ID is the user-defined thread ID. So we move the value of index into the private section, and the user-defined ID is this ID. So when a sorting thread is being created, it uses the second argument to set its user-defined thread ID. Because when this thread is constructed, there's no neighbors, of course, and the number is not there, so it's not defined. Then you construct a channel name for that. Now, because when a user thread is created, it has no neighbor, but it has a predecessor. The predecessor constructs this thread. So we create a synchronization 1-to-1 channel using new. We allocate a synchronous 1-to-1 channel with a channel name constructed here. And this is a channel from the predecessor to me. My thread ID is given here and saved here. So my previous one is definitely the current one minus 1. In this way, we assign user-defined thread ID in a sequential way, 1, 2, 3, 4, 5, 6. So this is the constructor. Now, because in this constructor, we create a synchronous 1-to-1 channel. We add a destructor, which has a tilde here. We delete that channel. If you don't do that, memory leak could happen. So please study this constructor carefully before you move ahead. And this is the code of the sorting thread. This is the first slide. There are some little things on the next slide, which is the end section of this thread function. So always do that. And we have 2 numbers. One number serves as the received number. The other temporary number is served as a comparison. And we get the thread ID, return the ID of a thread. This ID is not the user-defined thread, which is different. So we have a big loop here, this while loop here. So when we get to the while loop, this thread receives a number, which is just an integer. Then is this number equals end of data. If the newly received number is the end of data, then the game ends here. So we break this while loop. Otherwise, if the number I memorized is not defined, which means this number is the first time I get, so memorize it. Or it's not the first number. So I test to see whether the number I just read in here is greater than or equal to the number I memorized. If it is the case, the newly received number is going to be sent out. So this number to be sent out is saved to temp numbers. Otherwise, if the number is less than the number I memorized, I know I am going to send the number I memorized there. So the number I memorized is here. I save the temp number and then use the new number to override the number I memorized. Up to here, I have determined which number should be sent out and whether I should memorize the new number. Then I check to see, do I have a neighbor? If there is no neighbor, then I create a sorting thread. So this sorting thread, in order to get a sensible name, I hope it's going to be 1, 2, 3, 4. It's the next one following me. So its user-defined thread ID is the next one following mine. So that is a sorting thread created. The pointer returned will be my neighbor. Then run my neighbor. Up to here, if there's no neighbor, then I will be here. So up to here, right before this blue line, I either created a successor or I have already had a successor. In both cases, I have a channel to that successor. Of course, this channel is not built by me. It's built by my successor. Therefore, I am ready to call the send method of my successor. So that is my successor. I call it its channel and the channel send. Send what? Send the number I don't want, which is an integer. After it is done, go back to return next number. So before you continue, please pause and make sure you understand what's going on in this very important part. Okay, finally, this is the remaining. Here, this is big while loop was presented on the previous slide. So if this loop can reach here, that someone breaks this loop, it means this thread has already received end of data. Then it checks to see, do I have a neighbor? Do I have a neighbor? If I do have a neighbor, then I send my data to it. What that data is, end of the data. And then wait for my neighbor to finish its work. So if I am the last one, I don't have a neighbor, I simply exit. If I do have a neighbor, then I tell that neighbor, my successor, that it's end, but I do not end myself. Instead, I wait until my successor is end. So the creation and the end of this sorting thread would be first in, last out. Do you see that? I do not end myself until my neighbor exits. So all of my successor would exit before I can go. So this is the sorting thread. Then for the master thread, give it name. The master thread simply loops here for every iteration reading a data. Is it end of the data? If end of data breaks, otherwise it's just send the data input to the first sorting thread's channel. As long as the input is not end of data, we just loops here. Once this do while ends, we send end of the data to the first sorting thread and then exit. Finally, the main program. We have our first sorting thread here. So we have our first sorting thread followed by a master thread here. So first thing first, we create a sorting thread. The first argument is the sorting thread number 1, and this is for the next thread, sorting thread number 2, to be used as the user-defined thread ID. So we create the first sorting thread and run it, and then we create a master thread. This is sorting thread ID of 1, and then run it and join, and then join with the sorting thread. So here we create first sorting thread, create the master thread, and run the master thread. So here we have the master thread and the first sorting thread running. And then we wait for the master thread to end and wait for the first sorting thread to end. You move this one up, that doesn't matter. And finally, the main program exits. So this program looks a bit long, but the idea is very simple. If you understand the diagrams, we illustrate to depict how a linear array, linear sort by use of multiple threads. If you understand, this program is quite straightforward. So this is the end of this short discussion. And this is also the end of message passing. The next presentation will be a demo telling you how to use the visualization part of ThreadMentor. So it's near the end of this concurrent computing course lectures. I hope you like it. And goodbye and good luck.